a funding protocol. It's a capital formation protocol. And what we're doing with V4 is we're expanding it to be omni-chain. So it's a fork of V3 at its core, but then there are elements to the project that kind of decorate this core and add this omni-chain features set. And then we also have built a few applications that use and extend the core Juicebox v4 protocol to actually do certain application things. So I'm going to quickly give an overview of all of the repositories and components involved. So this first half of this thing will be just very architectural overview, and then I'll dive into some code chunks that I think are interesting to at least start with. And pardon me if I'm stumbling over my words. First thing in the morning for me, I'm at an Airbnb and I haven't had my coffee. But, you know, I've looked at stuff at this code for the past year and a half over and over and over again. It's been kind of a long project that a few of us have been working on. So to the extent, like as I go through this, I'm hyper familiar. I might skip over things. I might, you know, forget some obvious components because I've seen it 1,000 times. So again, feel free to reach out, but I'll do my best here. This is the document that I think a lot of the source material for the audit contest comes from. It's an auditor's guide, very simple, very, very short, but it outlines all of the repos. I think they've aggregated it into a monorepo, but here it should be organized on my blog. The structure is like, okay, so there's a bunch of infrastructure components, which are the kind of nuts and bolts of everything. And then at the end here, there's some applications that we've built using the infrastructure. The cool thing about doing it this way is, the infrastructure is very abstract. It doesn't really say anything specific about what the protocol should be used for. And as we get into the applications, we actually use some of these like hook endpoints that the infrastructure exposes to solve certain problems. And so throughout this audit, you'll see both the hook endpoint, like how a hook can be attached, and then a bunch of examples of hooks themselves. So you get a pretty end-to-end idea of how this Juicebox v4 ecosystem will work. If you fast forward and kind of look at the clients, this is out of scope of the audits, but just to give you an illustration of what some of these applications could look like. This Banny Looks collection is a NFT collection. Kind of hop in here and you can kind of play around and get an idea of, you'll be looking at the code that does all this stuff, but like application-wise, cool, you'll address your Banny. And then when you go to checkout, you'll be essentially paying into the Banny RevNet, is what we call it. And the RevNet component is a financial framework that accepts revenues and fundraises. And so there's a whole other app here, RevNet.app, that actually services the revenue from this NFT collection and other things in the span network. So you can poke in here and see where all of that code chunk is exposed and how it works and how it feels. All of this is still a Juicebox project, so all of this treasury, this RevNet band component is also exposed in Juicebox.money as kind of the, you can think of it as like the Etherscan of the Juicebox protocol, where you can also create projects and launch your thing that's maybe a little bit more fundraise oriented. So that's kind of like a quick overview of like what it might look like. You can see kind of the RevNet components here. I won't get really into how it fits in. You'll see that should be pretty clear. But just know that they're here, and this is what makes it all kind of interesting. The crop top component is interesting because all of these websites here, they all have, they're all kind of blog posts that I can go and mint. And this itself is a Juicebox project. All these blog components are Juicebox projects that work using this crop top component. Again, just illustrating here so you can see how it feels. So if I were to mint here, it would show up on my, like the Juicebox project that I have attached, which would show up kind of in the regular Juicebox logging interface as just an NFT. You get collect, but the funds all go into the treasury of the blog in that context. Um, cool. Okay, so that's kind of an application overview. Really quick, I'm going to zoom through this. There's so much details that I could get lost in, and I'm just going to try not to get lost in details. I'm going to try to focus. Okay, so crop top, RevNet, Benny looks. Now you have a cursory understanding of these applications. Let's work backwards here. Suckers is our component that, actually I'm not going to work backwards. Work backwards from the application, so I'm going to start from the top from the infrastructure here. I'll go through these one by one. Most of them are really small. The big chunker is core, and everything after core is pretty big, but core is like the V3 fork, and it is what, like when I think about Juicebox, it is everything is in core. Ownable here is a fork of OpenZeppelin Ownable that allows contract access not only to a specific address that owns it, but also to a Juicebox project that owns a contract. So you can kind of make sure, if I own a Juicebox project, which I will just illustrate what that means real quick. So I'm in core, I go to source, I go to JB projects, and you'll notice it's just an ERC 721, so every Juicebox project is an NFT, which is owned by, in this case, an address, right? It's an ownable, it's a regular OpenZeppelin ownable. And when I own the address, then I am the kind of owner of the project. So in this case, in this Defend Room and Storm campaign project, the owner is this address here, which is Gnosis Safe. So in this ownable component that I was just talking about, if I were to, write something that is ownable in this context, it's like, do I own the project of the with the provided project ID. Address registry here is a way for us to register hooks later and know which deployer deployed them. So it gives front ends a framework to determine legitimacy of hook components later. Project handles is a small contract that allows us to map a project ID to a ENS. So you can see here the routing of this goes to an ENS, but it resolves to the project ID. This is the same as in V3. All these components exist in V3 as well. There's a few nuances in project handles that allows this to work in multi-chain. So if I have a project on various chains, I can still I can resolve them to an ENS. Permission ID is very straightforward. It's just like a single file with a lib, but a lot of stuff in the Juicebox protocol is permissioned in this way, where you have a function you want to run. Let's say send payouts. You want to make sure that that either the address calling that function is the like has specific permissions, or that address has given operator permissions to another contract, and we use this all through this permission ID indexing. I'll give you a very quick example of a something that's permissioned. Let's see, require permissions. Okay, you'll see this a lot. The first line of a function is like, okay, require permission from this holder, and this is the project ID that it relates to, and here's the permission ID. Alrighty. And then we get to core. So core is the big chunker of a repository, but it has all you need to know, and it's actually fairly, like, for all it does, I think it's quite beautiful. I think it kind of condenses things well, it expresses things well, it organizes things well. We've been working on this for several years now and iterating. despite the protocol not really giving many affordances for migrations, for iterations, for kind of rug pulling the protocol structure underneath projects. It's very fixed. Like our first principles are that it's permanent, and we have there's very little governance oversight over the protocol. There's obviously no control over project funds or no access to changing things on the fly. We have a few methods for kind of proposing new versions and kind of giving projects their own opportunity to move funds over if they want to. But this V4 is going to kind of live as its own entity. And the general structure here, the, I'll start by saying all the READMEs are very complete. So the READMEs should be great, and I will be doing my best to write more documentation throughout this month as the audit goes in. But all the NatSpec and READMEs should be fairly strong, but here's the overview of how core works. Funds come into the terminal, the terminal contract through a pay call. So this is like your standard, when you click the button on Juicebox Money, pay goes into this pay call. And then it's going to do a routine. There's a few other kind of top level, and all the funds stay in multi-terminal. So the multi-terminal is like, has all the money of the protocol. Nothing else holds funds. So this is a very important contract. It's the point of, it's actually like, it's the gateway, it's the bank, it's all the stuff. You can, I'll take a step back and go to the directory now. The directory is a top level contract that basically maps project IDs to terminals, so you can see which terminal a project is currently accepting funds from for a particular token. So let's say the primary terminal of project ID, in this case, like Rectus is 771, it's a project ID. Yeah, so I can get the which terminal, which contract this project is accepting funds for this token is what the directory will tell me. It'll tell me all of the terminals if I have several places that I'm accepting funds from. Obviously, projects can bring their own terminals if they want to do something custom, but we also give the community's checks and balances to make sure projects can't simply bring their own custom code that does something irresponsible. And then the directory also keeps track of which controller is currently being used for a project ID. And the controller is kind of the central brain unit that actually manages minting tokens and actually accessing a lot of these other components from. So essentially the line of the chain of access, and I should have a drawing here to illustrate this, but I'll leave this for next week, a really complete diagram that actually outlines all this. But funds come into the multi-terminal. Multi-terminal is like, cool, I received some funds. What should I do next? I should mint some project tokens and send that back to the payer. Let me go talk to the project's controller. The project controller receives that call and is like, who made this call? Oh, it's one of the project's trusted payment terminals. Cool, I can process this. Let me now go to the token store and actually do the actual minting operation. So tokens in this case is you'll see a function mint, but it can only be called by the controller of the project. But it'll actually do the accounting for tokens and stuff like that. Same with splits. If you're kind of routing payouts to several splits, this is kind of one of those contracts that sit on the extremities of the protocol that can only be accessed by the controller. Probably the most important concept within Juicebox, within each project, is this data structure called a rule set. So you can think of a project as like, okay, you have a project and you schedule a certain set of rules. The rules are what happens when funds come in and under what conditions funds can go out. You schedule those rules. You schedule, a sequence of rules. So in V3, you can only schedule one rule set at a time. So I will illustrate what that looks like in V3 world. So for instance, right now, Erectus is running on a 3-day cycle, which means these rules are locked in place for 3 days. It has unlimited payouts. It's issuing 5,700 UJ per ETH. It's reserved 49%. The reserve tokens, you can see they all go to like Erectus.eth. So about half the tokens as they get issued go to their multi-sig, and then there's a bunch of other little rules. But the point being, these are kind of the rule sets that are fixed in place. In V4, you can schedule a bunch of these in advance, so you can kind of have project operations scheduled, and as they happen, as you come across those kind of time boxed rules, they'll automatically change. You can see that in RevNets. How they like, if you go to how it works here, you'll see this is working in stages. So stage 1 lasts like 600 days, and it has an issuance rate, it has splits, it has this cash out tax concept. So it's all kind of Juicebox stuff under the hood. And then stage 2 starts in 2026 and does this, and stage 3 starts in 2042 and basically shuts everything off. So all these rules are fixed in place, and they're all expressed in this JB rule sets contract. So now we're back in core. I just flipped through several tabs. Sorry if that's confusing. But now we're back in core and JB rule sets. This is like the scheduling engine of the whole protocol, and it's very important. So let's please make sure that we have scheduling as tight as we can get it. It is a little complex, but it is like, this is the big value prop of Juicebox. So you can get like an array of, you can get your current rule set, you can get like all your rule sets, you can see which rule set was latest to be queued, which one's upcoming, which one's the current active rule set. That's all this data structure, JB rule sets. So that's kind of like the data hierarchy of Juicebox. You have projects, which are defined as JB projects, and then projects have rule sets, which at any point in time you're in a rule set and certain rules apply. Then we have some price oracle things to allow projects to define their issuance rate given a certain token. Like for instance, Erectus is issuing their token as a function of ETH. So 5,700 UJ per ETH, but what happens if I pay USDC to the project? How does that get resolved? All that stuff kind of happens in this price oracle to make sure that it's all just, right now it's a chain link wrapper, but you can bring your own oracle and stuff like that. I think that's the general gist of core. There's a few like data components. Like your terminal store actually stores all the balances for the terminal, but I think that'll be pretty clear once you start making your way through it. Not much in the abstract stuff, not much in the enums, a bunch of interfaces, because all this is meant to be integrated with the outside world. Libraries, let's see what's important here. I think that's all pretty self-explanatory. And yeah, this is a bunch of structures, but those all kind of make sense in the context that you're looking at things through. Alrighty, I'm gonna zoom by and go to a hook, because really core is interesting, but it's more interesting once we understand how you can use core to do certain things. I'm gonna focus probably the rest of the session on pay hooks. So there's a few different kinds of hooks in core that are bits of contract functionality a project can bring and attach to any of the rule sets at any given time to add special powers into what happens when your treasury receives funds and under what conditions those funds can be withdrawn. One of these is a 721 hook. This is a hook that we bring. We kind of wrote it as a first-party community, if you will. there's not really like such thing as like first party in Juicebox world. It's just kind of an open community, but we use this quite often in kind of our flagship products. You saw earlier this campaign here has a NFT 721 hook attached that allows folks to get NFTs as they're contributing. You can kind of see it plugs in directly into the pay function. So let's, I guess before I dive in here, I'm going to show you where it attaches in the pay function, which is in core. I'm going to go back to function pay, it's internal version of the pay function. It's called. Um, Once I've done all this pay accounting, essentially, I will get to this section at the bottom that'll just basically like fulfill pay hook specifications. At this point, this function already knows which pay hooks I need to fulfill, and essentially, cool, I've processed the payment, now what do I need to do? And then the pay hook, the 721 hook, will be like, oh, cool, I was paid 0.1. That means I should issue this NFT. Or there is a metadata component to these pay functions. Right here, it's kind of the last argument, and there's a formatting structure here that allows the front end to pass specific information to the hook about what it's trying to do in the hook. So which NFTs it's trying to mint, for example. And this repo is just a pay hook infrastructure, essentially. So all that NFT stuff is accounted for here. At its very, in its abstract form, a 721 hook is a 721 that does all this pay hook stuff. So 721 hook, JB rule set data hook, JB pay hook. And it's also a cash out hook. So it allows NFTs to be redeemed, so basically burned to access a part of the treasury back if that functionality is turned on. So there's a few flags that determine whether some of these things are turned on or off. But the actual implementation of those hooks are like before pay recorded, and then after pay recorded. So you can kind of add hooks that core will reference. You know, should be pretty clear before the pay is recorded and after the pay is recorded. Okie dokie, that's 721 hook. Buyback hook is also a pay hook, and it's going to be logic that determines, so as treasuries are receiving funds, I'll go back to JBM here. So every project starts out with 0 tokens of its tokens outstanding, 0 in the treasury, and they issue tokens as funds come in. In the case of Rectus, again, 5,700. There's a world where, as the project is going on, a liquidity pool emerges on Uniswap, where previous buyers, for whatever reason, maybe the issuance rate has changed in subsequent rule sets, want to, are offering their tokens at a better rate than issuance. So a buyback hook you can attach to your project, and it'll essentially, as funds come in, it'll figure out, should I issue new tokens or should I buy back tokens from the market? So if the rate of buybacks is better than issuance rate, it'll route the incoming funds to the market, buy back tokens, and then fulfill all of its duties. Otherwise, it'll pipe the funds into the treasury and mint new tokens. So the buyback hook is just a simple contract. Again, it has that I guess from the interface perspective, you'll see the rule sets, the rule set data hook and the pay hook opening here, and it'll do the buybacks. This is what JB DAO uses right now. So it's got this attached, so whenever protocol fees come in from any of these projects, so any of these projects that are fundraising, as they pay out, 2.5% of those fees go to Juicebox DAO, which is kind of our community project. But we've been running for a long, long time, so all the fees coming in just get piped to buy back JBX from the market through the buyback hook. A few more components here. The swap terminal, this is fairly self-explanatory. I showed you what the terminal component looks like before in core, which is kind of your main entry point for actually processing payments and actually managing money. Swap terminal allows a project to attach another terminal. So you remember in the directory, projects can have multiple terminals. If they have a swap terminal attached, it means it allows kind of payers to pay in any token they want, and then there's going to be a real-time swap into a token the project accepts, and that'll be piped to their project. So it basically allows projects to accept various tokens, but only store the ones that they want to actually hold and back their tokens by. And that brings us to Suckers, which is the omni-chain magic component here. So everything you've seen is basically going to be just printed on all EVM chains, and we can extend to new ones as new ones emerge, and projects can choose which EVMs to exist on. They'll essentially accept funds on all of these chains and issue their unified token back out on all of these chains. So it'll be the same token address everywhere, but they'll exist not just on one chain to be bridged. They'll actually exist separately on various chains. And the only thing that ties all these things together is this component called Suckers, which essentially allows token holders on one chain to bridge not only the project's token, but also the underlying funds from the treasury from one chain to another. We have various components here that wrap the various native bridges. So Arbitrum Base Optimism are what we're starting with, and we have a CCIP one as well that allows us to be a little bit more flexible. And then there's a registry component where anyone can look at which chains a particular project exists on. So I guess by looking through this repo, you'll get a sense of the actual mechanics of how that works. But this is probably the newest part of V4. It is nuanced because we've had to pour through docs for all of these various communities to understand the ins and outs of failure conditions and stuff like that. So please make sure to review this stuff and make sure that we're not missing anything. And yes, there's a bunch of deployers here that allow projects to deploy their own suckers for various chains. So I think the most interesting subtle bits of this whole code infrastructure is going to be suckers. It's going to be core, insofar as core is very used. It's the most used contract. It holds all the funds, but it's also been around the longest. So it's pretty it has somewhat settled down into like a mainstay code. But please, it's delicate. Please review it. In core terminal obviously sticks out because it holds funds, but rule sets is probably the most nuanced bit here. So please spend time trying to figure out how rule sets work, verifying that all the expected conditions check out. And apart from that, there's if you're into more kind of fun stuff, you can look directly into the Banny Looks collection type stuff, or the RevNet collection, or rather the RevNet financial structure that wraps everything. Quick context: like RevNets work by essentially rolling a contract that is a project owner. So by being a project owner, a contract can enforce a set of rules to take place. Otherwise, a project's owner has complete permission to essentially change the rules later on as the project evolves. I think I at least vomited all the information on screen. I don't know if it made any sense. Just kind of hopping around tabs and stuff, but at least it's a cursory overview of what's going on. Based, can you take it from here and maybe point out what I missed or elaborate a particular component that's interesting to you or you want to share about?
I think you did a pretty good job and in covering the large aspects of everything. Um, let's see, I'm not entirely sure where. I mean, from here, it's a lot of very small, specific things. I think you covered all the big aspects of it. Unless there's something specific you want me to go into, I'm not sure where I can.
I think,
I think we should do. Go for it.
sorry, we could do a Q&A kind of a session where,
Oh,
off the top, if researchers have any questions, they could just ask right now. Uh, that could be one of the options. Additionally, we could give researchers a few days to go through the code base, and uh, uh, if based on your availability, we could do another session where now they have better understanding of the code base and they have different questions now, we could do another session if you're available. Yeah.
Both.
Yeah.
yes.
Yeah. So I think
Let's do Q and A.
yeah, we can do
Yeah,
let's do a Q&A. So whoever is online right now, please feel free to drop your questions in the chat.
I'll share my screen if needed again. But if
Yeah, sure.
anyone in the audience has questions or wants to say something, feel free to.
Sure. Or
Or
even
others,
just,
feel free to.
yeah,
Just like raise your
raise,
hand or
yeah,
however this works. Otherwise, we'll check back in next week.
all right. If you have questions, please type in the chat right now.
Alrighty.
Or
Should we call it
just,
Richie?
yeah, yeah, I think we don't have any questions. So if you do, just type something gibberish in the chat for now, and so that we know that you have questions. If not, let's catch up next week.
Cool. Alrighty. Thanks,
All right.
y'all.
That's good.
All right. See ya.